systems of equations. When we're dealing with systems of equations, it's all it means is you're solving two equations at the same time, or three equations at the same time, or four equations. It's just a multiple of equations that you're trying to solve at the same time to find out where are they all equal. And there are three possible outcomes that can happen, no matter how small or how large your system is. So if you've got a system of equations, we'll start with some two variable systems, and then we'll go up to three variable systems. We'll get any bigger than that. But these three outcomes are the same three outcomes no matter how large or small your system is. You can have three possible outcomes. One of those outcomes is that you have exactly one solution. And that another kind of the math way of saying that is that it's a consistent and independent system. So kind of tie those two together. You'll hear me say one solution most often, but that consistent and independent is another way of saying one solution. That's just kind of the mathy way of saying that. You could also have a case where those two equations or three equations have no solution, where they all meet at the same place. And that's also called an inconsistent system. So no solution is inconsistent. And the third option is the infinitely many solutions option. And that means that it just has so many answers we can't quantify it. We can't say that there's 1, 2, 3, or 5 answers. There's an infinite number. And an example of that would be like if my arms were two different equations. Infinitely many solutions would be like if my arms were slapped together, because they're touching each other in an infinite number of places. That's what an infinite number of solutions would be for equations. And it's kind of mathy term for infinitely many solutions is consistent and dependent, because wherever one goes, the other one depends on it to go the same direction. So that's the idea that goes with that. So these three possible outcomes, the most common one and the one we like the best is the one solution option. If you think about it, I think about with, did y'all ever see the movie Hidden Figures? That the ladies that did the math for NASA, and it's a really great movie. But some of the math in there they were talking about, they were dealing with a matrix or multiple equations. When you launch a rocket, there's a lot of variables in there, and so they were dealing with a lot of equations, and their job was to come up with that one solution. Well, if there was infinitely many solutions to it, then anybody could do it probably. If there's no solution, that means nobody could do it. But if there's one solution, that means it'll work. And that was kind of that go, no-go idea with launching a rocket. So when we're dealing with that, the one solution is going to be your most common thing to happen. So if you start doing the work and you start seeing a bunch of them that have no solution, something's probably not going right. Or if you start seeing a bunch of them that have infinitely many solutions, probably something's going wrong with how you're working them, because one solution is the most common way that you're going to get a system of equations in a math class anyway. It may not be real world situation, but in a math class, we want you to get us an answer most of the time. Okay, so let's look at first what does it even mean to do that? If we're talking about a linear system, linear system means straight lines. And when you're dealing with straight lines, maybe you got a coordinate plane with an X and a Y axis, and you got two equations on there, and one of them does that. There's a straight line. That blue line would have some sort of equation that went with it. It doesn't really matter what it is at this point. And then you could have another equation, maybe this red line, that they intersect, they cross each other. That place where they cross right there, that's the solution to the system. So that's an example of what the graph looks like if there's one solution. Okay, so one solution is where they cross in one place, and we're going to talk about that a little bit, and then do some algebra to show that that's happening as well. And then same idea. You got a coordinate plane. You got two equations. So we got that blue one that's shooting up through that way, and then maybe there's a red one that's shooting the same exact direction. And those two lines never cross. What's another name for lines that never cross? They're called what kind of lines? Starts with a P. Perpendiculars do cross at 90 degrees. If they don't cross, they're parallel. Yeah, parallel lines is what I'm trying to show there. It may not be a perfect drawing of it, but that's parallel lines, and that would be a no solution case. When things are parallel, there's no solution to them because they don't ever touch out of that. So with a linear system, parallel lines is an example of no solution. And then the infinitely many solutions picture, a little tougher to draw because stuff just kind of lands on top of each other. So you got one line, and then the other line just kind of falls right on top of it. And I'll kind of try to draw it just a little off kilter there so that you can tell it's two lines on top of one another. That the blue line and the red line are laying right on top of each other, so they're touching each other in an infinite number of places. Not even, you can't even count it all, but there's a ton of answers, and that would be a consistent and dependent system. But wherever the blue line goes, the red line is right on top of it, going with it. So that's the dependent part of that. Consistent just means it has answers. So this would be an infinitely many solutions. Infinitely many there. Okay. Now, when you're dealing with systems of equations, there's a few different ways to solve. So we're going to go through some of those ways to solve by hand, and then we'll get into the calculator stuff. And we will use the calculator exclusively on the larger systems that have like 3 variables in them. But the linear systems, I want to show you the hand way of doing things. And that first method for solving is called substitution. Okay, so let's just take a system. Let's say we had 2x minus y is equal to 2. And then the second equation was y equals negative x minus 2. Okay, we're trying to solve this system of equations at this, it's 2 equations at the exact same time. We're going to use substitution on this one because we have the second equation says y is equal to this stuff. Okay, so we get what one of the variables is equal to. So if you know something is equal to something else, you can substitute it. Kind of like when you're baking or cooking. Sometimes you might want to substitute. Instead of using oil, you can substitute applesauce by a certain amount in there somehow. I don't cook a whole lot like that. But it's a substitution. So if something is equal to something else, you can put it in its place. So we're going to take this negative x minus 2, and we're going to replace or substitute that in the place of y in the other equation. So we're substituting one thing for another in the other equation. So that gives us this equation, 2x minus, and I'm going to put parentheses, negative x minus 2, and then that's equal to 2. So I've taken this stuff, that's what y was equal to. So I replaced the y in that first equation with the stuff that y is equal to. So that's what substitution does. And then you're going to work that equation. Notice that now this equation over here on the right only has x's in it. So it's only got one variable. And that's easier to solve. Not necessarily easy to solve, but it's easier than solving the one that's got 2 variables in it. And so you're going to take that negative and distribute it across there. So we get 2x plus x plus 2 is equal to 2. And then simplify. We got like terms, x and 2x. That'd be 3x plus 2 is equal to 2. And then we need to get the x isolated. So we're going to move the 2 by subtraction. And when I do that, I get 3x is equal to 0. And one last step to get that answer would be divide by 3. And 0 divided by anything is still 0. So x is equal to 0. And we have half the answer. Okay, we got an x value. Now we need to find the y value that goes with it. So with substitution, you've got an answer for one of the variables. Now you need to find it for the other one. you get to choose where you go. If you want to plug into the first one and then solve for y, that's fine. I'm going to go into the second one because it says y is equal to this stuff. So once I work this stuff out with the number that I got for x, it's done. So I'm going to take this and substitute the 0 in for x in one of the equations. It doesn't matter which one. You pick the one you think is the easiest. I'm going to pick the second one because I really think it's the easiest. So it's y equals -1 times 0 minus 2. Notice I made that a -1 because it's understood to be a -1 in front of that. And then -1 times 0 is 0, and 0 minus 2 would be -2. So we get an x value of 0 and a y value of -2. What that creates for us is an ordered pair. Remember, ordered pairs are x comma y. That's how they're always in alphabetical order with the letters. So if the system that you're solving has A's and B's in it, it's always in alphabetical order. A first, then B. Okay, so make sure if they change letters, we typically use X and Y, but it's always in alphabetical order. So our ordered pair for the answer on this problem would be 0, -2. And that ordered pair is the final answer. What that means is that these two lines, if you graph them, they would cross at that spot at 0, -2 on the coordinate plane. That's what it means. We're using algebra to find that because sometimes if we're having to do it by a graph, if they don't land on a perfect spot, it's hard to estimate what they are. But with algebra, you can get the exact answer. Okay. Let's do another one with substitution and see if we can go from there. So example B, let's get this system. 3x plus 2y is equal to 11, and -x plus y is equal to 3. All right. So this one doesn't have it spelled out for us. It doesn't have one of the variables by itself yet. So that means I get to choose which one I get by itself. And when I look at this problem, I see the top one has a 3 in front of x and a 2 in front of y. And usually if it's got a number in front of the letter, I usually don't use that equation to get one of the variables by itself. I usually look for one like this second equation where you've got a 1 in front of each of the variables. It's usually a little clearer when there's only one of them has a 1 in front of it, like this y has a +1 in front of it. So that means it would probably be easiest to get y by itself on this second equation. Don't think that you always have to get y by itself. If it's easier to get x by itself, then you can do that. It doesn't matter which one you get by itself, as long as you solve for one of the variables. So I'm going to solve for y on this one by just adding x to both sides. If I add x to both sides, that cancels it out over there, and I get y is equal to x plus 3, or 3 plus x, whichever way you want to write that. Doesn't matter. Okay. Now, what that allows me to do then is take this x plus 3 and substitute it in the place of y in the other problem. That's using substitution. Okay, so we're substituting instead of y, we're going to put x plus 3. So we got 3x plus 2 parentheses x plus 3 is equal to 11. Then we distribute the 2 and work this problem to get x by itself. That's going to be 3x plus 2x plus 6 is equal to 11. Like terms, I got the 2x and the 3x together. It would be 5x plus 6 is equal to 11. Subtract 6. 11 minus 6 would be 5. That's going to work out real nice there. Last step's divide by 5. 5 divided by 5 is 1. So get x being 1. And then I can take that answer and plug it into any of these problems that are right here. If I want to plug in 1 right here in the first problem, get 3 times 1 plus 2y is equal to 11, I can do that. I think that's the more difficult way of going about it. I could plug it into this original problem here, -1 plus y is equal to 3. That would work as well. I'm going to go to this one there. I've got y by itself because it's easier to do. I can just plug that in there and go y is equal to 1 plus 3, which that's pretty easy math right there. Y is 4. And we get this ordered pair. Remember, it's x comma y. 1, 1, 4 is our ordered pair. So these two equations have one solution, and it's where they're crossing at the ordered pair 1, 4 is what's happening with those. Okay. So using substitution to find those in that case. All right. Let's look at an elimination problem. Okay, so this is another method. And one of the teachers at my high school, he's a big substitution guy. He likes to use substitution more than elimination. I happen to be the other direction. I like elimination a little bit better. Maybe it's just I just see it a little easier than substitution. But at the end of the day, you got to know both of them to be the most efficient that you can be. So if you can do substitution well, it's going to work every time. If you can do elimination well, it'll also work, but it may not be the easiest way of going about it. So being able to do either or on the methods can be helpful in doing the problem quicker and more efficiently. So elimination, what you're doing is you're eliminating or canceling out one of the variables. That's going to be our goal. It's not to get one of the variables by itself, like with substitution, and then plug in. The idea is to eliminate one of the variables in the system. Okay, so let's look at this example. 3x minus 4y is equal to 1. And then this one would be negative 3x plus 6y is equal to 7. So when you're doing elimination, the idea is to look at the system of equations and make sure the variables are on the same side. So both of these equations are in standard form. They have x and y on the same side and in the right order. X, then y, then equal to a number. Make sure they're like that. If you're going to try elimination, they got to be in that order. Okay. Now, the next thing you look for is your goal is to have opposites on one of the letters. And for this one, we see that 3x and negative 3x, they're opposites of one another, right? So we don't have to do any work to get opposites. If they weren't, we might have to multiply by something to get there. We'll see some examples like that in a minute. But here, because they're already opposites, I can just add these two equations together. And the reason I want them in the same order is because I'm going to add the x's together. Positive 3x plus negative 3x, what happens to them? They cancel out, just like I was, the whole name of the game is eliminate. So positive 3 and negative 3 eliminate one another because they're both x's. And then we have a negative 4y and a positive 6y. So negative 4 plus 6 would be positive 2y. And then 1 plus 7 is 8. So we end up with this really easy and short one-step equation to get y. So we solve that for y. We just divide by 2. And y is equal to 8 divided by 2 is 4. So it makes, one of the reasons I like elimination so much is because that my second equation that I got to solve is super quick. It's a one-stepper every time. Okay? If I do the elimination right, I only have to do one step to get my answer for my first variable. The drawback to it is that I don't have an easy place to go plug back into. So I've got to do a little bit more work on the back end of it, but that's okay because I got one of my answers real quick and easy. So I took this 4 and it's what y is. So I'm going to take that y and substitute it back into one of the equations. It doesn't matter which one. just pick one. I usually don't even think about it. I always just go back to the first one when I'm doing elimination and just use it. Because if I start thinking too, there's always going to be pluses and minuses no matter what choice you make. Usually, it's that way in life. It's that way in the algebra too. So there's going to be a positive and a negative to it anyway. So I'm just going to take that 4 and I'm going to take it and plug it back in for y in that first equation. If you want to use the second one, if we do it correctly, we'll both get the same answer. It doesn't matter. So I've got 3x minus 4 times 4 is equal to 1. And I've just got to solve that equation. So that'd be 3x minus 16 is equal to 1. And then I'm going to add 16 to the 1. It'd be 3x is equal to 17 this time. And last step, divide by 3. And I get a fraction, and that's okay. That's one of the parts of life. Fractions. It's going to happen. Okay. Using algebra to solve this system, we found exactly where these two lines would cross. They would cross at the ordered pair 17 over 3, comma 4. If we were to graph those two, get y by itself on both equations and graph them, it'd be very difficult to eyeball 17 over 3. That 3 goes into 17 5 times, and with 2 left over, so it'd be 5.6 repeating. I don't know how many. I don't know. You guys may be better than I am, but I can't eyeball the difference in 5.66 and 5.7. It'd be very difficult to eyeball that. So that's where the algebra method of solving is better than the graphing method for that. So here we had opposites at the beginning. We didn't have to do anything to get them there. So let's look at one that maybe we got to do something to the equation to make them turn into opposites. So let's take example D. Let's say we had 9x minus 12y is equal to 3, and 2x plus 3y is equal to 12. So there's our system of equations, and we want to try to use elimination to solve that. So when I look at those, they're in the right order. I got x, then y equal to a number. So they're in the right order. Most of the time, they're going to be in the right order. Just kind of check for that first. It's the most simple thing to check for. And then you start looking at the numbers in front of the variables. So 9 and 2, can I turn a 2 into a 9 by multiplying by something that's pretty easy? Well, 2 times 3 is 6. 2 times 4 is 8. But 2 times 5 is 10. So it doesn't work real nice there. But then I look at this 12, the negative 12 and the positive 3. Can I turn a 3 into a 12? Well, 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So that's my ticket right there. That's the one I want to try to eliminate, is the y's, because I can turn this 3 into a positive 12 to make opposites. That's my goal here, is to make opposites. So because I want to change the y to a positive 12, but I can't just change one part of a problem. If I change anything, I got to change everything in that problem. So I've got to multiply this entire problem by 4 in order to get the y to change. Turns out it changes the other stuff too, and I get 8x plus 12y is equal to 48. The first equation, I'm not changing at all. I'm just going to copy it over. So I just copied the first equation over. The second one, I did some work to it to get the opposites. And then once I've done that and got opposites, I add the two equations together. The 12y's cancel each other out. I eliminated y from my problem. And now 9 plus 8, 17x. 3 plus 48, 49, 50, 51. I have 17x is equal to 51. That's a one-stepper. Divide by 17. Everybody knows their 17s times tables, right? No, I didn't learn them when I was a kid. That one's familiar to me because I've done it a million times, but it's 3. That goes. So x is equal to 3. That gets me half my ordered pair. And now I want to go back and solve for y in one of the equations. Again, it doesn't matter which one you plug it into. I'm going to go into the second one this time because I got smaller numbers in it. 2 and 3 instead of 9 and 12. There's a 12 in the second one too. It doesn't matter which one you plug it into. Just pick one and go. Don't sit there and fret over that. It's not. It's going to be the same amount of work. 2 times 3 plus 3y is equal to 12. So then that's 6 plus 3y is equal to 12. Subtract 6. 3y is equal to 6. And the last step, divide by 3. And y is going to be equal to 2 in this case. So we get this ordered pair, 3, 2. X first, then y. So using elimination to get rid of some stuff. Look at this one. Let's say we got 3x minus 2y is equal to 4. 5x plus 4y is equal to 8. And let's try to use elimination to solve this one. Same idea. We'll use elimination on this one. And if they gave me a choice as to how to solve that, either by substitution or elimination, I would know that elimination would be a better idea because none of these have a plain variable. I usually don't use substitution unless one of them already has a plain variable because that usually will introduce fractions, and I'd rather not work with fractions if I don't have to. Sometimes I have to, but I try to avoid it if at all possible. So they're in the right order. Everything's good to go. So I'm looking at the coefficients of the numbers in front of the letters. 3 and 5. Turning a 3 into a 5 doesn't work. Same way turning a 5 into a 3 doesn't work real well. But I can change a 2 into a 4 pretty easily, right? This -2 I could turn into -4 so that I have opposites by just doing what to the first equation? Yeah, multiplying it by 2. If I double the first equation, that'll give me 6x minus 4y is equal to 8. And then the second equation is 5x plus 4y is equal to 8. And then because I've got opposites on the y's now, I'm going to eliminate y. Don't always have to eliminate y first. Just whatever works to get opposites. That's what you're looking for. So here we're going to get rid of the y's. It's going to give me 11x is equal to 16. Well, that's not perfect in terms of what we would love to see. We'd like for it to work out nice, but it doesn't. In this case, we get a fraction for x, and that's okay. It's not a big deal. It just means we got to do a little work with some fractions here. And then you just pick a variable or pick one of the equations to plug that x in for, either the top one or the bottom one. It doesn't matter. Pick one. I'm going to go with the top one here just because it's not much difference either way. So it's 3 times 16 over 11 minus 2y equals 4. I'm going back to the original when I do that, just because I've made the problem bigger when I'm multiplied by something. So I'm multiplying 3 times 16 over 11. That'd be 48 over 11 minus 2y equals 4. I'll subtract 48 over 11. I'm going to use the calculator to help me out here. 4 minus 48 over 11 enter math, enter, negative 4/11. Negative 2y is equal to negative 4/11. And then I'm going to divide, the last step would be divide by negative 2. So I've got parentheses negative 4/11 divided by negative 2. We'll hit math, enter. Positive 2/11. So y is equal to positive 2/11. Ordered pair, 16/11, 2/11. That would definitely be very difficult to, if you had to find that on a graph, where, you had to graph those to solve. It would be very difficult to see an eyeball 2/11 and 16/11. Very difficult. All right. So elimination, trying to get rid of one of the variables, no matter what, sometimes you may have to multiply both equations by something to get that to happen, but you're just trying to get opposites is the goal of that. Let's look at this one. And with this one, you can use, choose your method. So either substitution elimination, I don't care which way. 8x minus 2y is equal to negative 4. And then negative 4x plus y is equal to 2. And again, either method is going to work. No matter which method you like the best, it will work. If you like elimination, use it. If you like substitution, you use it. It's fine. It's okay. On the final exam or on the quizzes online, I'm not going to be able to tell which one you used to solve it. But one way is usually quicker than the other. For this particular problem, I don't think it really matters. It's short enough but I would probably use elimination, but I lean that way anyway, kind of person. I like elimination anyway. So what would you multiply by here to do elimination with? Yeah, if I multiply the second one by 2, that's going to give me negative 8x plus 2y is equal to positive 4. And the top one's not changing. And then when I add those two together, what happens to everything? Yeah, everything on the left side goes away. Positive 8x and negative 8x cancel each other. Negative 2y and positive 2y, they cancel each other. And then negative 4 and positive 4 cancel each other. So what we end up with is this situation here. Does 0 equal 0? Yeah, I'm pretty familiar with 0. It's usually how much money I have. And it's always equal to the same every time. 0 is equal to 0 always. This is a true statement. Anytime that is a true statement after you've done your substitution or elimination and all the variables cancel out, if you've got a true statement left, that's going to be one of those cases where you have infinitely many solutions. Okay, so if all the variables cancel and it's a true statement, 0 equals 0, you might end up, if you did substitution, you might end up with something that says like 2 equals 2 or something like that. But it's true, whatever it is, it's true. Then it's going to be an infinitely many solutions situation. All right, so there is an example of one that has an infinite number of solutions. Let's look at one that may or may not have that. We've done several that had one solution. We've done one that had infinitely many solutions. So you can kind of guess where we're headed with this next one. Not very surprising. And again, you can choose your method. It doesn't matter which one you use. It's going to work the same, problem the same way. It's going to get you an answer. And not necessarily good or bad either way. Okay? For this problem, I would probably use elimination because I don't have a variable that would be easy to get by itself. If I tried to solve the top one for x, I got to divide by 3 at some point, and 4 isn't divisible by 3, and neither is 2. Same thing happens on the bottom one. So this is where, that's how I usually decide. If I'm going to use substitution, I got to have a plain x or a plain y in one of the equations. If I don't, I'm going to use elimination. That's why I use it more. So if I'm going to eliminate here, I'm going to multiply the top one by 2 to get opposites. So that's going to be 6x minus 4y is equal to 8. And then the second one is not changing. It's still negative 6x plus 4y is equal to 7. When I add those two together, again, the x's cancel, and here, so do the y's cancel. So that's 0 on the left side. But on the right side, I get 8 plus 7, which is 15. Does 0 ever equal 15? Never. Okay? If you got $0 in your account, spending 15 can't happen. It's not supposed to happen anyway. Sometimes your debit card will let you, and then it costs you $30 more. So this is a false statement. Anytime the variables all cancel out and you get a false statement left, that is a no solution situation. Because that is all the variables canceled, we have a false statement at the end. Okay. So substitution, elimination, same rule. If all the variables cancel, that's when you'll have either an infinitely many or a no solution. All the variables got to cancel out. If the variable is left, you got answers. Okay? So only way that's going to happen is that all the variables cancel out. If it's true, what's left is true, infinitely many. What's left that's false, it's no solution. Most of the time, you can see we've done, 8 examples here. Only 2 of them are ones that are special cases. The rest of them had one solution. Most of the time, you're going to have one solution. So I always kind of go back and recheck those with that when I get a weird one like these two. Okay. All right. So there's 2 ways to solve a system of equations. I'm going to show you the third way, which is the calculator way. And you may or may not like it. I don't know. I like it for the larger systems. The 2 variable systems I can usually do by hand pretty quick, but I've done a lot of them. You probably, I've been doing math since I was, this kind of math since I was 14. So we won't say how many years that is, but so I've done a lot of them. You haven't done as many as I have. So this may be your way, and I'm fine with it if it is. Okay. The matrix method for solving that. And what we're going to use is what's called an augmented matrix. Okay? And reduced row echelon form. All you got to remember is RREF. You don't have to remember what reduced row echelon form is. RREF, the abbreviation, is what you need to remember for that. Okay, so RREF and an augmented matrix are what we're going to be using here. And what's going to happen is you need to have your system in the same order as if you were going to do elimination. Okay, where x's and y's are on the same side and they're in order out of that. So example would be something like this: 3x minus 4y is equal to 1, and 5x plus 2y is equal to 19. That's our system that they give us, and they ask us to solve it. Maybe they said use substitution. Maybe they said use elimination. Maybe they said use the matrix. It doesn't matter. Using the matrix will work no matter what method they get. And you'll get the same answer no matter what method you use. All of the methods for solving systems all should end up at the same place. Whether you use Google Maps or Apple Maps or MapQuest or TomTom or Garmin or whatever, if you type in the address for your UTM center, they should all take you to the same place. way with solving systems of equations. No matter which method you use, you should end up at the same place at the answer. Okay, so an augmented matrix, what that means is you're just taking the letters out of the problem, and you're going to come up with this 3, -4, 1, 5, 2, 19. What we have here is a 2-row by 3-column. So we'll write 2 by 3 there. 2 rows. Rows go horizontally. 3 columns. An X column, a Y column, and a what they're equal to column. Okay? So always going to be the size is how many equations do you have? The columns, the rows, that's how many equations you have. The columns are variables in alphabetical order. So we got 2 variables here. We got X and Y. So that's X, Y, what they're equal to. We'll get to a bigger system in a little bit that's got 3 variables in it. The same idea, you just make it a little bit bigger. Okay. All right. So we have a 2 by 3 system. That is the augmented matrix. Okay. It's augmented because it has what they're equal to in the problem. Okay. Now, what we want to do is put this into our graphing calculator. So I want to show you how to do that. Okay. So everybody grab your graphing calculator for a little tutorial on this. And the good thing is you're going to have the YouTube video that you can go back to and rewatch this as many times as you need to. I go over this in one of the lab video for systems of equations as well. So you're going to see it several times. So you hopefully pick up on it. Okay, so we're at the normal calculator screen here where we're starting out. So I just cleared my screen so we didn't have any other clutter there. So what I'm going to do is I'm going to hit the blue second button. And then I'm going to go straight down that left side until I get to the X inverse button. And right above it in blue says matrix. So it's the button right below math. And it should take you to what I call the matrix menu. So you've entered the matrix, if you like that movie. The first column or first selection are just the names of the matrix. Okay, so I've got some stuff in matrix A, B, and C that I've used. Who knows when I used that last. I bet some of it is from the lab that I made a video of earlier this week. So we got the names of them. The second menu, if you press the right arrow key, is the math menu. We're going to use that some tonight. We'll use it some to solve this. But this is where you do your work. Okay, so this is the math part of that is where you do your work. We got to get this matrix in the calculator first. So that's where the edit is going to come in. So we're going to go over to edit. I'm going to select matrix A. If yours has something in there already, that's okay. We'll get rid of it as we go. Okay, mine already has some stuff in there. I'm going to get rid of mine. So I've got mine on edit and selection number 1. I'm going to hit enter. And it should take you to what it calls matrix A. All right. And now, what size was our matrix in example H? It was a 2-row by 3 column. So the size is the first thing you put in there. So we want to put a 2, hit enter. Notice how it changed the size of my matrix right then. It made it 2 rows. And then it has 3 columns. The one we want to use has 3 columns. So I'm going to put a 3 and hit enter. And it should resize that matrix to a 2 by 3 matrix. It should look like 2 rows and 3 columns. Mine has some numbers in it already, but I've got to replace them with the correct ones for my problem. My problem, the first row should be 3. So 3, enter. The second column in that row is -4, enter. And then the third one is 1, enter. And then it just drops me down to row 2. So again, let's go through that step one more time. So I'm going to hit second, X inverse, go over to edit, hit enter, 2 by 3, and then you put your numbers in. 3, -4, 1. 3, -4, 1. And it just writes over the top of whatever you already had in there. All right. And then the second row, I need a 5, 2, and 19. So 5, enter, 2, enter, 19, enter. Okay. Once you have your matrix entered correctly, go back and look and make sure you got all the signs right. Because if you missed a negative sign on any part, it's a completely different problem for the calculator to do. Okay, so you got to make sure everything's in the right spot. Mine is, so I'm ready to go back to the regular calculator screen. So I'm going to hit second and the button right beside it that says mode, and that'll take me back to the regular calculator screen. And then here's where we're going to go to the matrix menu and do the math part. So we're going to hit second matrix, go to the math menu, and we're going to go to the RREF, that reduced row echelon form. So the quickest way to get there is to press the up arrow key, because it's kind of down at the bottom of the list. And if you'll press the up arrow key, it'll get you down there to the bottom quicker. And then I'm going to just press up until I get to RREF. Notice there's an REF and an RREF. We want the double R. Okay. Reduced row echelon form. That's what that stands for. We're hitting enter. And then it says, okay, you want to do RREF? Perfect. What do you want to do that to? We need to pick the matrix name that we put it in. So second matrix. And I put mine in matrix A, which is the one I use the most in anything that I do. So matrix A. You don't have to close those parentheses, so I'm not going to. I'm just going to hit enter. It cranks back a reduced matrix that has the answers in it. It comes back with this matrix, 1, 0, 3, 0, 1, 2. What that matrix tells me is that x is equal to 3 and y is equal to 2. The first column is the x column. It says 1x plus no y's is equal to 3. The second row says 0 x's and 1 y is equal to 2. So that's where I'm getting this. X is equal to 3, y is equal to 2. And so we get an ordered pair, 3, 2. We're going to do a few of these, so don't worry about if you didn't catch it the first time. You'll get some chances to pick it up as we go here. All right. So let's take another system. Let's take this one. X plus y is equal to 2, and 2x plus 3y is equal to 5. All right, so we're going to put that in as a matrix. The augmented matrix that we would use would be 1, 1, 2, 2, 3, 5. I write that down just so that you see what it should look like when you get there for the augmented matrix. You don't have to have it there, but it definitely is nice to be able to just glance at and look at it and see what's going to have. So got to have 1, 1, 2, 2, 3, 5. So I'm going to go to second matrix, go over to edit. I'm going to use matrix A again because it's already the correct size. So I'm just going to hit enter. And 2 by 3, it was already that size. And I'm going to put my stuff in. I got a 1, 1, 2. So I'm just hitting the number and then enter. And it goes to the next spot. And then the bottom row is 2, 3, 5. 1, 1, 2, 2, 3, 5. Second, quit to go back to the regular calculator screen. And then we need RREF again. There's a couple different ways to do it. Once you've done it once, you can copy and paste. If you press the up arrow key with your calculator until you highlight that and hit enter, it'll copy and paste it down. Or you can go through the second matrix over to math and then pick up RREF again, and then tell it matrix A. And here we have a solution. We have 1, 0, 1, 0, 1, 1. This tells us that x is equal to 1, y is equal to 1. So we have the ordered pair 1, 1. Out of that one. Could have gotten that with substitution. Could have gotten that with the elimination. It works either way. Okay. So we have this one. X plus y equals 2. And then 2x plus 2y is equal to 5. So a very similar system, but just one number changed in that system. 1, 1, 2, 2, 2, 5, as opposed to 2, 3, 5. And let's see what that does to that system. So I'm going to go to my calculator. I'm going to second matrix. I'm going to go over to edit, matrix A. It's already the right size, so I'm just going to press the right arrow key until I get to the spot I need to change. I need to change that to a 2 and hit enter. And now I've got the matrix in there correctly. So second, quit. And then I'm going to do the RREF on the matrix A. And I get this weird looking one. 1, 1, 0, 0, 0, 1. Look at that bottom row. That bottom row tells the tale, okay? It says that 0 x's plus 0 y's is equal to 1. How can 0 plus 0 ever equal 1? It can't. So this is a no solution problem. Okay. So that bottom row, if you get all zeros and a number over here, it's going to be no solution. What do you think would be in this last spot if it was infinitely many solutions? All zeros across the whole bottom row. If the entire bottom row is zeros, then it's an infinitely many solutions situation. We'll look at that in just a little bit. Okay. Let's look at a larger system of equations that has 3 variables in it and see how using the matrix can be useful in solving that. So let's say we had this one. X minus y plus 5z is equal to negative 6. 3x plus 3y minus z is equal to 10. X plus 3y plus 2z is equal to 5. So here we have 3 equations. So our augmented matrix is going to have 3 rows. And we have an X column, a Y column, a Z column, and a what they're equal to column. So that's 4 columns. So we're going to have a 3 by 4 augmented matrix that we're going to put in there. So we have 3 by 4. 3 rows because we got 3 equations and 4 columns. So 1, negative 1, 5, negative 6. 3, 3, negative 1, 10. 1, 3, 2, and 5. So that's the matrix that we need to enter into our calculator, is this 3 by 4 matrix that we're dealing with there. Okay. All right. So second matrix, Go over to edit. I'm going to use matrix A again. It's just a little less button pushing to use. And I'm changing the size to a 3x4. So 3 enter, 4 enter, and then it sets you up to start putting that in there. So we got 1, -1, 5, -6, and then the second row is 3, 3, -1, 10. 3, 3, -1, 10. And then the last row is 1, 3, 2, 5. 1, 3, 2, 5. Okay. On these, it saves you time if you'll go through and make sure you got everything the same way. So 1, -1, 5, -6. 3, 3, -1, 10. 3, 3, -1, 10. 1, 3, 2, 5. 1, 3, 2, 5. Okay, so I got everything in there, the right spot, the right sign. Once you've done that, same story. Second, quit. And then you're going to use RREF on matrix A. So second matrix, math, RREF, matrix A. And I get this 3x4 reduced row echelon form of the matrix, which tells me 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, -1. What that tells me is that x is equal to 1, y is equal to 2, and z equals -1. It's a 3-variable system. We get an answer for x, y, and z. The answer is written in what's called an ordered triple instead of an ordered pair. You got x, y, and z. X, comma, y, comma, z. That's how we want to write it. So 1, 2, -1. That's our solution to that system of equations. If you took x, y, and z, these answers here, and plugged it in for x, y, and z in each problem, it would check, it would work in each of those problems. Okay. That's what we're finding here. All right. If you do a 3-variable system and you end up with 1, 0, 3, 6, 0, 1, 2, 5, and then 0 across the bottom. That 0 across the bottom is going to tell you that is infinitely many solutions. Okay, infinitely many solutions. If you do a matrix for a 3x4 system and you get something like this, 0, same, looks almost the same so far, but then you end up with this. That bottom row again tells you that is no solution, because there's no way 0 plus 0 plus 0 could equal 1. So be able to recognize those and be able to use that matrix to solve a system. I'm not asking you to do 3-variable systems by hand, period. That is, I don't think that's a valuable skill as far as the world we live in right now, for sure. I don't know many mathematicians that sit there and do that for fun. I don't think it's useful for you. So I'm not going to ask you to do that. On the 2-variable systems, the methods to do those by hand, we're going to use those on nonlinear systems. So that'll be something that'll be useful to you because you can't use a matrix on a nonlinear system. But I'm okay with you using the RREF to solve the 2-variable systems as well, even on the labs, and that'll be noted on the lab assignments that you get today. Okay. All right. So that's the first two sections. Let's take a break because it's been a good bit here, and come back in. Let's see. Let's be back at 5:25. That'll give us 10 minutes there to kind of chill out and do some things.